Right. So as the first part of this animation montages section, I think I covered this upper body, lower body split mask. And now let's implement the upper body pose cachings in order to play the animation montages. Right. So at the end of this filtering, we have this upper body, lower body split, and we can use it to filter out the upper body pose cache as well. So I'll use this upper body, lower body split pose cache, and let's pass it through this slot, which is upper body, and then I will make a new cache pose and call it as upper body slot. Right. And then we are going to apply another layer blend per bone. So I will use this upper body, lower body split and upper body slot as the input pins. And let's use layered blend per bone. And as the first base force, I will use this existing upper body, lower body split. And the second blend pose is upper body slot. And the blend weight, I can keep it as 1. Right. And then as the filtering method or blend mode, I will use the branch filter, and we need to actually set up what are the animations that we are going to use. What are the specific bones that we are going to use for the filtering, right? So I will use pelvis bone to filter it out, and as the blend depth, I will keep it as 4. So these are actually pre-configured values that I found on Lyra sample project. But if you're using any sort of custom animations based on your animation requirements, you can tweak these values. But if you're using Lyra animations, I think going with these default values would be nice. And that's the first bone. And as the second bone, I will use right thigh. So thigh underscore R, which is -1. And the third bone is thigh L. Again, I will mark it as -1. Right. So you can see the animations now will be applied for the bones that are up in this specific bone, right, which is the pelvis bone. So you can look at the skeleton as well. So you can see the pelvis bone is here, and we have like set of spines to signify the upper body, something like this. And we have thigh L as the lower body and thigh R as the other side of the lower body, right? So I'm simply applying the animations for the bones that are up from the pelvis bone, right? So it will be the upper body animation that is being played, and other bones will be ignored, right? So that's why the blend depth is marked as -1. Okay. And then I can use the blend here, right? And as the B value, I can use the upper body slot as well. And for the alpha, I think we need to dynamically determine what is the upper body alpha. Right. But before resolving it, I'll promote this existing cache pose to a new cache pose, and I'll call it as upper body pose. Right. Okay. And I'll comment this section as upper body catch. Right. Okay. And then let's resolve this upper body alpha. Right. So how can we do that? I think we can create a new function like this, update blend weight data at our blueprint thread safe update animation. So at the runtime, the alpha value for upper body will be resolved. Right. So I'll create a new function called update per body alpha. And this is a thread safe function. And as the input, I will get the data time. And in here, I can call that function right after the character state data and before update blend with data. But I think you can use these two stuff interchangeably. The order of these two won't matter because these are just simply figuring out the two different alpha values separately. So you can use either this pattern of execution or this pattern of execution. Either would be fine, right? Right. So I will plug the delta time and let's go inside that function and start implementing it. Okay. So as usual, I'll create a new variable called upper body alpha and assign it to montages category and plug it to here. Right. So now we need to interpolate this alpha based on certain conditions. And let's see how we can do that. So first I will get this upper body alpha and I'll interpolate that float into a specific target value. So for now I'll keep it as 0. And as the delta time, I can use the delta time that this function passes. And as the interpolation speed, I will keep it as 10. And the return value will be the upper body alpha. So now we need to figure out what is the target value actually. So it can be either 0, it can be either 1, or it can be any sort of intermediate value, right? But I think the target value for in our case, it should be either reached to 0 or 1 based on the certain conditions. So what are those conditions? Right. So let's start with the initial condition. So I'll select float based on certain conditions, right? So if this condition is true, then I need to reach to 0. Otherwise, I need to remain at 1, right? Basically, there is no interpolation in between the existing upper body alpha. So when I'm reaching to 0, well, there are certain conditions. So the first is basically if I have an acceleration for a specific target direction, then I'll interp the existing upper body alpha to 0, so it will be smoothly blended that specific animation montage, right? And the second condition goes with actually animation curves. So we have these curves, right? So one thing is like this turn your curve. So if you look into the turn animations that we have, for example, this unarmed turn left 90, we have this curve called turn your weight, right? So based on these curve values also, we can smoothly interpolate the upper body alpha based on this specific curve value, right? For example, if we are playing this animation and at this sort of area, we are not going to play the existing animation montage, because this area the turn is being applied fully, right? Because the curve value is larger than 0. But in this sort of area now the turn has been completed, which means like we can play the animation montage, right? So based on the value passed by or returned by this specific curve, we can determine which areas we should play the animation montage and which areas which shouldn't play the animation montage, right? Okay, so you can use this turn your weight curve to have this condition, or have this switching in between float target values. So I'll use this existing curve turn your weight as the name of the curve. I'll get the curve value out of it. And I'll simply check if we have a positive value at this curve, which means we are basically providing the priority for that specific turning animation instead of playing our existing animation montage. So if this one is greater than 0, then I'll pass it to here. So it will choose 0 and the existing upper body alpha will be interpolated into 0. Okay. And there is another curve that I want to add, like if I need to specifically disable the lower body for any sort of a custom animation, I should be able to do that based on a curve value, right? For example, let's say I don't know, maybe I'm going to use, let's say, this gray stone cast, right? So for example, let's say in this specific area I don't need to play specific animation montage, right? And then I should be able to do that. So for that I will add a curve and I'll call it as maybe disable lower body, right? And I can edit this curve based on the keyframe values, right? But for now I will keep it as 0, but later on actually if we need to disable a specific area of animation montage that is being affected, then I can make certain key values and make this curve up, right? So if this curve has a positive value in that specific area, then we can smoothly blend the animation montage that is being played, right? Same as what I explained at the turn animation, right? So in the turn also we are going to use a curve, I think this one, turn your weight. So similarly we can actually add a curve to in order to custom as a custom curve, so in order to restrict animation montage is being played, right? Like I mentioned at this graystone cast, right? Okay, so I'll use this curve value at here, but first I will create a new variable called curve disable lower body, type of name, compile. As the default value I will provide the exact same name, disable lower body. Right, so I'll copy these things, and instead of the curve turn your weight, I can use this one, a curve disable lower body, and then I can plug it to here, right? Okay, and then if this condition is true also, it will reach to 0, the target value will be 0. So with the time, the upper body alpha will be interpolated to this specific target value, which is 0, right? Okay. And I think the name of this function is not correct. Should be update upper body alpha, right? So there is a small typo. Now I'll assign it to the blueprint thread save category, compile and save. And we can go back to our montage slots. And there we can use that variable. So let's go for the upper body alpha. Okay. Right. Now the upper body animations are also there. So now what I can do is, as the final pause, I can use that cache pause. So it should be upper body pause, right? Because that's the final cache pause that we have here after filtering in between multiple different branches. Right. And I'll comment this as final pause. Compile and save. Okay. Now I think the montage implementation related stuff for this specific animation instance is done. So it was sort of a long process actually, because there are certain conditions and there are certain filterings and calculations that we need to do in order to have a proper montage slot animation layer, right? And I think this is a good position to stop the second part of the montages, right? And as the third part, I will explain how we can actually use these implementations at our blueprint level to play specific montage animations, right? I'll see you there in the next video, and thank you.